Hey Science Mustangs, it's week 9, the week before report cards, which go out next week, so make sure all of your assignments are caught up. This week's assignments won't be on the report card, but last week's certainly will. Make sure you're ready. Last week we covered the digestive system, which takes in food and water, sends the nutrients and necessary H2O to your body cells, then eliminates the solid waste. Yeah, poop. This week we cover the excretory system, which takes care of the liquid waste. Right again, pee. Ain't science cool? That's all coming up this week. Be right back. All right, let's get right into it. I'm not going to spend any time going over the stuff we do every week, the learning targets and the vocabulary. That should be habit by now. You have just 2 assignments this week. The first is an ed puzzle. You've done one of these already, so the only new thing is the subject, the excretory system. Below the video, you will find diagrams, articles, and videos, all describing the excretory system and how pee is made. I'll bet you always wondered about that. Anyway, all of the vocabulary is included in the reading and videos, so look for them there. Then go to the Google Classroom for the ed puzzle. Remember to run the ed puzzle video all the way to the end, or it won't send your work to me. The second assignment is more involved and takes on a concept that we're going to need to become familiar with: homeostasis. Homeostasis is like equilibrium or balance, but it's dynamic. That means it's constantly changing in an effort to keep the system from becoming unbalanced. Someone on a treadmill. The treadmill keeps the person from moving, but it constantly has to move itself to keep the runner stationary. That's fixed or not moving, at least as far as the position of the runner is concerned. And that's because the runner is moving. So is the treadmill. This is dynamic equilibrium, or homeostasis, which refers to natural systems like the earth and animals and us. So that's how homeostasis works. The air temperature changes, or you exercise, and your body heats up. You don't want your body temperature going up too high. That's not good for you. So your body does something to cool itself down. Do you know what that is? Exactly, sweat. The sweat evaporates and carries heat away from your body. Relax and cool down a little, you stop sweating. Your body is trying to maintain a constant temperature, somewhere between about 96 and 99 degrees Fahrenheit. This Gizmo's lab explores that concept. Let's take a quick at the Gizmo's lab interface, the GLI of science. Okay, I won't steal any more of Bill Nye's stuff. On the left side is the simulation window. This is where you take your data of measurement from. This is the dependent variable window. Click on the Tools tab at the upper left and you'll see the tools to take screenshots or place arrows to point to some important detail you want to make more noticeable. You can also get help on the program and turn the sound on and off. In this left window, you'll see the fatigue level. This is like the health level in a video game of your character. Water level is just what it sounds like. How much water does the body have to use? Not enough? Heat stroke. Fortunately, you can't give the person more water than they need. Next to that is the sugar level. This is the glucose your body cells need to operate. Again, not enough, your body wears out. So you need food to go. That's how you get your energy. You also have thermometers on the right and left side of the screen that tell you what the air temperature is and what the body temperature is. Your objective: don't let the body get too cool, hypothermia, or get the body too hot, hyperthermia. To do that, you use the controls on the right. On the right is the control panel. This is the independent variable stuff, the stuff you control, things you can take and change as the lab operator. You can make them work harder, you can make them sweat, you can give them food and drink, and place them in different positions to help them maintain their energy, the sugar level, and water, and body temperature. The play, pause, and reset buttons are also here to start the simulation, pause to take readings or measurements or alter settings if you need to, and reset, which erases everything and starts over. Take some time to play with the simulation to see what happens. With the different settings, different things are going to occur. So you want to know how the person is going to react. Also, watch the time at the bottom of the screen. The time goes real fast. It takes about 2 seconds for about an hour of simulation time to occur. So bear that in mind, because you don't want to be running your person ragged and having them die on you. Now we get to the work. Back on the haiku page, open the lab report document and start reading. Read carefully. Follow all of the instructions. There are 3 questions on the front page that you need to answer before you start the experiment part of the lab. Do the warm-up, then activity A, and finally activity B. There's about 4 pages in there. Activity B asks you to take a screenshot. That's in that tools menu, and that needs to be put in the report. So do that part at some point as well. But make sure you've got good readings and read the procedure. All right, always follow and read the procedure so you know what's going on. Remember, this counts as a lab grade, which is the same as a quiz grade. Do a good job. If you email me or message me about what you're supposed to do, the first thing I'm going to ask you is, what does the procedure say? So make sure you're familiar with the procedure before you start emailing me or sending me messages about, I don't know how to do this, because I'm going to ask you first, what does the procedure say? And then you're going to need to tell me what the procedure says and what you don't understand about that part of the procedure. So that's it. The interactive lab should be fun. Act like the person in the simulation is you, just like you would if you were playing a video game. You want to stay alive, right? You don't play a video game to sacrifice all your lives in the first 5 minutes, do you? I mean, that would be silly. Like always, email me with questions and problems, but be specific, please. When you say, I don't know how this works, doesn't tell me what this you're talking about. You got to tell me what this is. If you ask about an assignment, read the assignment description first before you send your email. The answer is probably already there. So, until next week, to paraphrase our principal, remember, it's great to be a science Mustang.